Hello everyone. In this presentation we are going to discuss about the significance of the encoder in a mobile robot. So what you see in front of you is a mobile robot which contains the wheel of 9 centimeter radius, which is connected to the shaft, which is connected to the gearbox, which is connected to the motor, and the motor shaft is connected to the encoder. So in our discussion we are going to talk about the encoder. What is the encoder? Encoder will help us to identify the number of revolutions as well as the degree of turn, so which will help us to identify the speed of rotation, angle of rotation, and lot more for the computation. So in our presentation we are going to focus much on the encoder. The encoder what we are using is Orange OE 775 encoder. So this will help us to find out the number of revolutions by using what principle? By using Hall sensor principle. The setup of this encoder is based on the Hall sensor principle. So here we are using this OE 775 RS775 because we use RS775. It can produce the 7 pulses per revolution. As you see here, it can produce 7 pulses per revolution. That means one rotation of the shaft will produce 7 pulses. That is what we need to understand. So this is the internal circuit schematic of the encoder, where the supply voltage and ground can be given, and then there is a comparator and the schematic triggered output is taken out. As we all know, schematic trigger is a good noise cancellation circuit. After noise cancellation, the output is pure square waveform. You can see the square waveform output here, which is the output of the encoder. So if you want to see the motor and encoder physically, I can show you that, which will help you to understand much more. So if you see here, so this is the motor which we are using this here. So this is the DC 12 volt motor. So this is the motor shaft. This is the motor shaft. Here we used to connect the encoder, and this is the gearbox, and this is the gearbox output shaft, which is connected to this gearbox output shaft is connected to the chassis diagram. This chassis diagram output is connected to this. In this point we will connect a wheel like this, as you see here. So the motor, here we have connected the rotary encoder, here we connected the wheel, here we connected the setup. So this is the setup. So the motor with gearbox, back side we will connect a encoder, in this side we will connect a wheel. So we will talk about this in detail and the significance of encoder as best as possible, and then we can demonstrate how best it works. And the encoder part, what you see in this laptop is, this is what the encoder, which 2 Hall effect sensors, and we have a magnet here. So this magnet will produce this, and the small circuits will produce 7 pulses per revolution. So this is connected and then connected together, as you see here. So there is a VCC ground, and the pulses are taken out, and then we are able to see it in an oscilloscope, something like this. So before going to the output waveform, we are going to discuss the theoretical part of it. As we see here in this so this is the setup what we have seen. So there is a motor with a gearbox, and there is an encoder which is connected to the wheel. So if you look at the gearbox ratio, there is a 19:1 ratio. What do you mean by the gearbox ratio? 19:1 ratio means 19 revolution of the motor shaft. That means, so if you see this, so this shaft, if it rotates 19 revolutions, so this shaft will rotate 1 revolution. So that is what. So why there is a gearbox? To provide more torque. As we all know very well, gearbox will provide more torque. So 19 revolutions of this motor shaft will produce 1 revolution of this gearbox. So because of the gearbox ratio of 19:1 according to the specifications. So here according to the encoder specification, it produces 7 pulses per revolution. So 19 into 7. So when the wheel has to rotate 1 revolution means, so 19 into 7 you will get 133 pulses per revolution. Okay, that means for 360 degree turn we will get 133 pulses. So approximately for 3 degree turn we will get 1 pulse. For every 3 degree, encoder produces 1 pulses. Okay, so when you look at the wheel now, so this is the wheel which we are using it for our robot. So this wheel has a radius of 6 centimeter. This wheel have a radius of 6 centimeter, and if you find the circumference of this wheel by using this formula 2 pi r, and so 1 revolution of this wheel will travel 38 centimeters. 1 revolution of the wheel will travel 38 centimeters, which is 380 millimeter. So distance traveled per pulse means 380 millimeter is 1 revolution, and then for 1 revolution we are getting 133 pulses. So 380 divided by 133, so which is approximately 3 millimeter. That means for every 3 millimeter distance, encoder produces 1 pulse. So when this robot moves 3 millimeter, this encoder will produce 1 pulse. So 3 millimeter accuracy. So for example, I want to make this robot to travel 6 millimeter, means I can drive this motor until I get 2 pulses. If I get 2 pulses, means it could have traveled 6 millimeter. So that is how it works. So up to millimeter accuracy I can make the robot to travel forward as per my expectation. So that is the beauty of encoder. So where every 3 millimeter this encoder will produces 1 pulse. That is the one you need to understand from this discussion. And so 90-degree turn. So we are going to make an experiment here. So we are going to make an experiment here. If you see here, here the motor shaft is given. Here the motor shaft is given. So with this nose plier, I am going to make a 90-degree turn. So what do you mean by this? If you make a 90-degree turn, means 90 degree divided by 3 means it will produce 30 pulse. So 90-degree turn will produce a 30 pulse. So 90-degree turn will travel 30 pulses into 3 millimeter, means it travels around 9 centimeter. So the same wheel with this robot will travel 9 centimeter if the wheel turns 90 degree. For 90-degree turn it will produce 30 pulses. That is what we are going to experiment with this setup. So in this setup, so there is a motor which is connected with an encoder. The encoder we have provided a power supply. Encoder we have power supply from the digital power supply. So we given the 5 voltage, and the output of this encoder is given to an oscilloscope, as you see here. Okay. So now I am going to make a 90-degree turn. So now if you see this, so the oscilloscope is here. Now if you see here, I am going to make a 90-degree turn. So now it is 0 degree. I am going to make a 90-degree turn. So let us see the output waveform. So now after turning the 90 degree, so we have got the waveform like this. So we are about to make a 90-degree turn. That is our objective. We are about to make a 90-degree turn. So now let us assume this is 0 degree, and I am going to make a 90 degree. So this is 90-degree turn. And if this is considered as 0 degree, maybe if this is considered as 0 degree, and I am going to make a 90-degree turn. So this is 90-degree turn. So for the 90-degree turn, it produces this many pulses as per our discussion. So as you see here, so these are all the pulses from this waveform you are able to see. These are all the pulses which was produced by the encoder for 90-degree turn. We are expecting the 30 pulses per 90-degree turn. Okay. So if we start counting, so pulse falling edges, right? 1 and then 2, so 3, 4, 5, and then 6, 7, 8, 9th falling edge, 10th falling edge, 11th falling edge, 12th falling edge, 13th falling edge, 14th falling edge, 15th falling edge, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25 and 26. So 26 pulses has come for approximately 90-degree turn. So when you leave it as a run mode, and then we come out from this, so every turn produces pulses, as you see here very clearly. So with the help of this much accuracy, with the help of encoder, it is very comfortable for us to identify the angle of rotation as well as the speed of rotation in one direction. Thank you very much.